Hey, good morning, everybody. This is Mr. Ainsworth, and we are in Algebra 1 here, Chapter 6, Section 1, and we're going to be talking about how to solve systems by graphing. There's multiple methods, and there are three that we're going to go through. The first of which is graphing by systems, or systems by graphing. Sorry, got that backwards. And the second of which is substitution method, and then elimination, or what's called the linear combination method. And we are going to go through them all. But first, we need to get a handle of what a system is and how to solve it by graphing. And since you're good at graphing linear equations, well, this should be a breeze. Okay. First of all, in the book, homework, which we will do eventually here after our practice, is on page 367, 1, 3, 15, 17. And it's a couple good problems right here. Really, couple good problems are 20 and 34. Those are the word problems here, the application problems. So make sure you do those when we're ready to do them. All right, and then of course I've got homework attached and exercises to practice on in class. So let's go through the definition of a system first, and let's get some practice. It's not that hard. Make sure that you have a red pen and a ruler. Okay, so get a red pen out for annotating. All right, and a ruler or a straight edge. All right, so we do some good graphs because you can't find the solution to a system without being really precise. Okay, and to do that, you got to have a ruler or a straight edge. So get your tools and then let's begin. All right, first of all, the definition of a system. All right, now a system is very simple. It's two or more equations. Two or more, greater than or equal to two. All right, solve simultaneously where the solution is a point, or a set of points that satisfies both equations. Visually, it is the intersection of the lines. Ooh, that is an important point. It is the intersection of the lines in a linear system. If there is no intersection, well, guess what? There's no solution. All right, so no intersection means, well, no solution, right? You got to have an intersection to have a solution if that's what it means to solve a system. So here we go. We're going to solve a system of two linear equations. It only has two right now, not three. All right, and we're going to state the intersection, which is the solution, as an ordered pair, x comma y, or here x comma y. And then afterwards we will apply it, okay, in terms of an application problem after we do some basic examples. Okay, so we got a linear system here. Y equals 2/3 x plus 2, y equals negative 1/3 x minus 1. What we want to do is graph them and find the intersection. So we have to understand that we have two equations here in slope-intercept form. Y equals mx plus b. It's called slope-intercept form. And I gave both in slope-intercept form because this is the basics example. In the further examples here, I have them in standard form where we have to isolate y. Okay, that's more challenging, a little bit higher level problem. But right here we have them in slope-intercept form, so I can see that right here that the slope is 2/3. Okay, I can see that right here, and I can see that the y-intercept is 2, or 0, comma 2. There's your y-intercept. Now, 2/3 means up 2, right 3. Keep that in mind. Okay, it's always rise divided by run. So let's graph that. 0, comma 2. Let's go up 2, right 3. Up 2, 1, 2, right 3. 1, 2, 3. Let's reverse it. Down 2, 1, 2, left 3. 1, 2, 3. So notice that we have 3 points that line up on the line, so get your straight edge out. Okay, and draw your line right through those points. There we go. And let's label it y equals 2/3 x plus 2. Okay, next line, what do we have? Well, we have slope is negative 1/3. That means down 1, right 3. The y-intercept here is negative 1, so b is negative 1, or 0, negative 1. So we're going to plot here at negative 1 on the y-axis, because again, it's the y-intercept, right? So it's on the y-axis. That's why we call it the y-intercept, okay? It's where the line crosses the y-axis. And then we're going to go down 1, right 3. So down 1, right 3 from that point. Just count. Reverse it. Up 1, left 3. Up 1, left 3. 1, 2, 3. Oh my God, we hit the other line. Oh, that's a point in common. Guess what? That's called the intersection. I just found the solution right there. It's that simple. Okay, so we draw the other line. And notice they intersect right here. All right, they intersect at -3 comma 0. All right, this is -3 right here. There we go. So there's the intersection. Okay, intersection. Everybody say intersection. Okay, at is -3 comma 0. That's the point that satisfies both of these equations right here. And in my next lesson here, we're gonna take the solution right here, and we're gonna substitute it in both equations. And guess what? It satisfies both of them, not one, but both. All right. And it's easy to check, by the way. Okay. All right. So we just look for the intersection, which is the solution as an ordered pair. We state it. That's all there is to it. So if you can graph a line, well, this is a piece of cake. All right, now let's take a look at the next system here. We got y equals 3 and y equals -2x minus 3. Well, this one right here, y equals 3, can be written like this. Y equals, let me write slope-intercept form above it here. Notice that there's no x term right here. And if there's no mx term, guess what? M has to be 0. So it's 0 times x, and then, well, you got this 3 hanging around. That's got to be the constant. That's got to be b. So m is 0 and b is 3. So the y-intercept is 3 and m equals 0. And guess what? If you have a 0 slope, it's horizontal. Okay? All right, so, or you can do this. You can take this and you can go over here and you can form 2 points, right? Make up 2 points where y coordinate is 3, like 1 comma 3 and I don't know 4 comma 3, and you plot them. 1 comma 3 would be right 1 up 3. 4 comma 3 would be right 4 up 3, and then you graph the line. Take your straight edge out, and okay, there you go. That's y equals 3. All right, like I said, it intersects the y-axis at 3. The y-intercept's 3. Let's call the y-intercept right here. And the slope's 0, which means it's horizontal. So draw a horizontal line through 3. It's that simple. Now this one here, on the second one here, m is -2. That means down 2, right 1. Y-intercept is -3 or 0 to -3. Let me just look at it right here. So you got to start at -3 on the y-axis, and you got to go down 2, right 1, which is right here. Reverse it. Up 2, 1, 2, left 1. Up 2, left 1. Up 2, left 1. Oh my gosh, I just found the intersection right there. So I start here in the y-intercept, and then I use my slope. I go either down 2, right 1, or I go up 2, left 1. Up 2, left 1. Up 2, left 1. And right there I just found my solution. Whenever you intersect the other line, you have a solution. It's that simple, guys. All right, so there it is right here. So let's highlight it. There's the intersection. All right, it's at -3 comma 3. All right, so -3 comma 3. There's my solution. Wherever the two lines meet is the intersection, and it represents the solution, which satisfies both equations. All right, that's all there is to it. So let's get some more experience. So here we go. We got 2y plus x equals 4, and we got x equals -2. So let's analyze both. All right. So if you don't know that this line is vertical, well, then you do a couple things. You remember 2 points determine a line, so you form 2 points where the x is -2. So how about -2 comma 3 and -2 comma 0? The x coordinate has to be -2 and y can be anything. So you plot them. -2 comma 3, -2 comma 0. And look at that, it's vertical. Okay, so this is a vertical line passing through -2. So let's label that. So x equals -2. Excuse me, this is a vertical line. Okay, x equals a constant equals a vertical line. Now this one here, You can grab 2 points, you can use intercepts to graph it, or you can solve for y. If you solve for y, go ahead and subtract x. Negative x plus 4 is the same thing as 4 minus x. Same thing, just different order. Divide by 2. The reason why is because, well, guess what? The inverse of multiplying by 2 is dividing by 2. You always divide. You always do the inverse. Okay? And so you get 1y, or y is equal to, ooh, look at that, negative 1 half x plus 2. All right? 4 divided by 2 is usually 2, especially right now. So your slope right here is negative 1 half, and your y-intercept is 2. So let's plot it to b is equal to 2. That's your y-intercept. Your slope is right here. Negative 1 half means down 1, right 2. So down 1, right 2. Down 1, right 2. We just reverse it. For a slope of negative 1 half, you can go down 1, right 2, or you can go like this. You can go up 1, left 2. Same thing, right? So you go up 1, left 2. Oh my gosh, up 1, left 2. All right, and look at that. I found my intersection. It's right here. Okay, so let's go ahead and grab the line tool and let's graph your line. Notice where they intersect right there. So intersection, my solution is at, let me see, left 2, up 3. So negative 2, comma 3. There's my solution. That's all there is to it, guys. You just grab both lines like you normally do, all right, and you find the intersection and you state it. That's it. Now, something a little bit more challenging is both in standard form. So you have to solve for y on both, or you have to use your intercept method, okay? Whatever you choose. There's a couple different methods for this, as you guys already know. So if on this one here, you solve for y, you got to subtract 2x. You get 4y is equal to negative 2x plus 12. You can write it as 12 minus 2x, or you can write it as negative 2x plus 12, because I added the opposite to both sides, right? Okay, now divide by 4. Always divide by the coefficient of y. And we have y is equal to negative 1 half, reduce your fraction, times x plus 3. All right, 12 divided by 4 is usually 3. So my slope is here, my y-intercept is here. So let's graph the y-intercept here. This is the y-intercept of 3. And I'm going to use my slope down 1, right 2. So down 1, right 2. 1, 2. Down 1, right 2. Reverse it, up 1, left 2. Up 1, left 2. So go ahead and get your straight edge out and draw your line. So this one right here is your first equation. All right, and let's draw the other one, or graph the other one. So let's solve for y as well. So we get y is equal to negative x, whoops, negative x, let me be precise, plus 2. 2 is positive. 2 minus x is the same thing as negative x plus 2. So my slope here is negative 1. Look right there, okay? So again, this is the slope, and there's your y-intercept. And so b is 2. So let's graph the y-intercept at 2, and then I have a negative slope. So I go down 1, left, right 1, down 1, right 1, down 1, right 1. Let me be specific here. Negative 1 over 1 is down 1, right 1. Reverse it, up 1, left 1, up 1, left 1. Ooh, I just found my intersection. See, if you keep on repeating the slope, guess what? You can find where the lines meet. And they meet right there, okay? Where? Let me see. At negative 2, comma 4. So my intersection here is at negative 2, comma 4. That's my solution. That's all you do, guys. All right? All right. Okay, so now let's apply what we've learned. And let's take a look at a biology example. Okay. This is a pretty cool one because it involves alligators. It kind of reminds me of my sister. She lives in Louisiana. And she took me to an alligator farm. Oh my God, it was pretty cool. All right, and I learned about alligators. So here we go. So scientists studied weights of two alligators over a period of 12 months. Ooh, the initial weight and growth rate. Oh my God, rate of change. The slope of each alligator are shown below. After how many months did the alligators weigh the same amount? So let's highlight the question because that's what we want to answer at the end, all right? After how many months did the alligators weigh the same amount? Okay, so let's interpret. So the first alligator, alligator number one, this small little guy over here, only weighed 4 pounds, but and his growth rate, because he was little, I guess, was 1.5 pounds per month. The second alligator, well, he came on kind of big. That's why he's bigger in the picture here. He weighed 6 pounds, but his growth rate was slower. It's only 1 pound per month. The question is, after how many months? How many months did they weigh the same amount? Keyword same, equal amount. So let's figure this out. Well, I mean, we could do it just by looking at a table because this is a fairly easy problem. However, we're going to model the problem. That means form a system. Model the problem. Model means make a system. Make a system means write the equations, guys, of equations that relate the alligator's weight over time because weight depends on time. The weight depends on time. All right. So the weight of alligator is equal to the initial weight plus, all right, the growth rate times the time. All right. So if let's say we use t for time, a good variable, huh? And let's say the alligator's weight is w for weight. So w equals weight. All right, t equals time. All right, in this case, let me see. This is rate of growth is 1.5 pounds per month. Ooh, per month. Okay, so this is time in months. So the t is time in months. Weight is pounds. All right, so we define your variables first. You don't always have to use x and y's, guys, okay? You use variables that make sense with the situation. So define variables first. All right, and now let's go for it. Alligator 1, okay? A1. So alligator 1 is 4 pounds initial weight. So it's 4 pounds. Excuse me. Let me start over here. So W for the weight is equal to 4 pounds plus, all right, the growth rate, all right, which is 1.5 pounds per month. So 1.5 pounds times the number of months, which is T. All right. For alligator 2, well, what's his weight? His weight is, let me see, 6 pounds, right? 6 pounds plus 1 pound per month. So 1 times T, or 1T. You guys, this is the same as like y equals mx plus b. All right, instead of y and x, I'm using w and t. All right, so let me rewrite this. W here is equal to 1.5t plus 4. And then here on this one, W is equal to 1t, or just t, actually. All right, plus 6. Why do I do that? Well, it kind of looks like this. Y equals mx plus b. All right, your slope here, this is your slope and this is your y-intercept. This is your slope and this is your y-intercept. Okay, so when you graph the lines. So when we graph this system here, we kind of have to define what the x and y axes look like or what they represent, because I switched the variables here a little bit. So instead of the x-axis out here, okay, it's the t-axis for time. So time in months, that is. Okay, so the time in months here, instead of axis, so this is t. And instead of y, well, this is w. All right, weight in pounds. So this is weight in pounds. Okay, so here we go. So to graph the first one here, the alligator 1, I got a y-intercept of 4 so over here, let me see. The slope is equal to 1.5 or 1.5, which is 3 halves. All right, up 3, right 2. And it has a y-intercept of 4. So here we go. So y-intercept of 4, and I go up 3, right 2. 1, 2, 3, right 2. 1, 2. All right. 1, 2, 3, 1, 2. There we go. Now the other one. What's the other one? Let's see. Let's do it. Well, actually, let's do it again. 1, 2, 3, up 2. Okay. The other equation. Okay, the slope's 1, but the y-intercept's 6. So slope of 1 is equal to 1 over 1, right? Up 1, right 1, from y-intercept of 6. So let's graph that. So on this one here, well, I got a y-intercept of 6, so we go up 2, 4, 6. Here's 6 right here. All right, there we go. This one's 4 here. So we go from there, we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Ooh, we just found it. Up 1, right 1, up 1, right 1, up 1, right 1. So these lines are not, um, too different, but they are different, of course, because they're sloped differently. And notice that they intersect right here, right there. There's the intersection, which is the solution. All right, so let's take a look at that. So let's go down. Okay, right here, that's 4. 1, 2, 3, 4. 1, 2, 3, 4. And let me see, this is 2, 4, 6, 8, 10. Okay, so this right here is 4 comma 10. So what in the world does that mean? This is the solution, 4 comma 10. So 4 comma 10, what in the world does that mean? Well, let me see, this is the time in months. So this is the time in months, and this is the weight. All right, so what we can say is that this means that we, in 4 months, they have equal weight and they're both 10 pounds. So in 4 months, all right, they both weigh 10 pounds. They both weigh, whoops, probably don't want to say that. Say they both weigh, there we go. 10 pounds. Okay? State the solution, what it means. Ooh, it just did, okay? So on application problems, guys, what you want to do is you want to solve the problem by modeling it first with this system of equations and use your techniques of solving the system by graphing, and then you have to interpret the solution and what it means. And you've done that before with me. All right, you always have to interpret the meaning of your solution. All right, and all you guys have to do is practice. All right, now attached to this is your homework, first of all, so your classwork actually. So you're going to do your classwork, and then after that, what you're going to do is you're going to do your homework in the book, and you're going to be doing all of this right here. All right, and all your work here, when I ask you guys to do this, all book work, all right, is done in your spiral. So done in your spiral, and you guys are used to doing that. So go with the flow, give it your best. When you do your book work, you can check the odd answers and some of the evens in the back of the book. Remember to do that. And remember, this is a video, all right? So if you need to, you can watch it again. So, or rewind it to any section you want so you can have a better understanding. So I went through a lot of different cases here. All right, use the video to your advantage. I'm here to help you, and I'll see you in my next lesson. This is Ainsworth. I'm out of here.